Okay, so let's switch to English and let's get started. As I told you, entity framework is over and we will start with a completely new topic. I hope you are ready for something new and you are interested in how to build APIs. Let's take a quick look in our course calendar to see what we planned, what we have done so far, and what will be the content of the course in the upcoming weeks. We have done a lot of C# at the beginning of the semester. We have then switched to link and things like that. We have switched to entity framework and talked about various topics on entity framework. Some things we didn't cover in very much details, but don't worry, we will cover that later. And now we are here in this area where we talk about things like JSON and web API design and so on. As you all know, this year's semester, because of the COVID thing, will be a little bit shorter than originally planned. So therefore, I had to make slight adjustments to the content of this semester. And I decided that we will drop for the moment this topic of JSON in C#. We already did some JSON in C# in the previous weeks. Remember that we imported JSON files. We have worked a little bit on JSON serialization, so we have pretty much covered the basics, and I think you are well equipped with these basics for the topics of the upcoming weeks. So this is not that important. And my heart isn't bleeding when we drop that one from this semester. I would like, for the remaining time of the semester, to focus on web API design, ASP.NET Core, and OpenAPI Swagger and things like that. So this will be the topics of this week, next week, and maybe the week after, okay? Essentially, what we are going to cover is how to build professional web APIs, RESTful web APIs with ASP.NET Core. You might wonder, you might ask yourself, hey, we have already created web APIs, even in the last exam. You have written web APIs in the last exam. That's true. But you have only scratched the surface of ASP.NET Core and of the topic of designing web APIs based on HTTP. So what we are going to do today and in the week and next week is we are going to dive deeper. We are going to talk about how to really design an API properly, how to use things like API, HTTP verbs, status codes, cookies, and headers and things like that. So we will talk about the conceptual topics. And then we are going to switch gears, go into ASP.NET Core and take a look at more advanced features of ASP.NET controllers in order to build APIs which fulfill the conceptual ideas that we designed at the beginning of this lesson. Today we have, I think, 5 hours, if I can remember correctly. Therefore, we have a pretty long time. We will not do theory for the entire time. On the contrary, I will try to make the theory part as short, as compressed as possible, but as long as necessary, of course. And then you have the chance to immediately try out what we discussed in the theory part. So you will have 1 or 2 hours, we will see, for trying out the things that we cover in the theory part. I have worked out an exercise that you can do that covers pretty much all the things that we will do in the theory lesson. So today, again, we have a combined lesson. I will tell you a little bit of theory. Of course, theory means that we will build a sample together. It's not theory in slides, but we will build the API together. And then you have the chance to try that on your own in your own exercise based on a classroom exercise, okay? The exercise is not very long. I will ask you to do the rest as a homework, but don't worry, I know you have a lot of exams currently, so the exercise is not very difficult. You will be able to build it within, I don't know, an hour or two. It's nothing complicated. Good. Nice. Let's get started. You can follow along if you want. If you want to follow along, please open swagger.io. If you want to just watch me describing some things, that's fine too. I will tell you when it's absolutely necessary that you start the development environment on your own computer and follow along. Currently, it's pretty okay if you just follow along by watching me telling you some theories, things in the moment, okay? The topic that we are going to talk today is called Web API design and then, of course, implementation. What are web APIs? Web APIs are APIs which are based typically on the HTTP protocol. There are other kinds of remote procedure call APIs like gRPC, for instance, or WebSocket, SignalR, and so on and so on. But we are talking today about Web API design for Web APIs which are based on the HTTP protocol. The HTTP protocol is well known for everybody of you from the browser. Of course, when we open a website like swagger.io, we are opening a website using an HTTP protocol. I'm pretty sure everybody knows that. Well, I know you know that because you have covered that in previous lessons. But just to remind you, to remind you what HTTP is all about, because maybe you have forgotten some aspects of HTTP, let's quickly dive into it and let's recap what this HTTP is really all about. So if I reopen this page and I press F5, as you can see it here, I've opened the page here in the development tools of Chrome. Then we can try, let me reload this guy. Okay, so let's for instance take this one. If we take a look what an HTTP request consists of, we can see that here. The first thing that everybody is well aware of is the URL. Of course, every HTTP request has a URL. The second one is something that sometimes people forget. The second one is the request method or the verb. You will hear both words for that. A request method can be, in this case, post or get or delete or patch or put or head or options, and there are many different request methods. What are the most important ones? Please listen closely. I will tell you that over and over and over again, and I'm pretty sure that I will ask you that. If you will do an oral exam with me, it's pretty sure that I will ask you some question about that. The request method get is for, as the name suggests, reading data. The request method delete is for, as the name suggests, deleting data. The request method put and the request method patch are for updating data. Get, read, delete, patch and put, updating data. Okay? You have to remember that. That's really important. The next one is the status code. This is a status code indicating whether the server could successfully process the request that came from the client. You all know status code 200, and there are many other famous status codes. Like, for instance, 500. It's an internal server error. 404, not found. But there are many other status codes. Let me quickly show you some things about this HTTP status codes. Wikipedia English. Here, list of HTTP status codes. Some of you might not be aware that the first digit of the HTTP status code is pretty important. It indicates the general type of response. A 1 response indicates just indicates just an informational response. A 2 at the beginning means it was successful, but there are different kinds of success. 3 means redirection. The thing that you are looking for is no longer present here. Please go there. There you can find it. A 4 at the beginning means, hey client, caller, you did something wrong. You can change your request in order to make it work. A 5 at the beginning means, oh, I'm very sorry, the error, the mistake happened on the server side. Client, it doesn't matter what you change. The problem was on my side. You can retry it, but probably it will not work. So that's essentially the 5 first digits that you have to be aware of. Now these are the informational responses. We will not talk about them very much. There is only one which I like to point out, and I'm pretty sure that not all of you are aware of that. It's the 101 response. The 101 response is especially important when we are talking about WebSockets. I'm pretty sure you have heard about WebSockets. I'm not sure if we talked about it, but in other courses you probably have talked about WebSockets. In contrast to plain HTTP, WebSockets is a duplex protocol. So server and client can talk to each other in both directions. And WebSocket is initiated using the HTTP protocol. So first, the client talks to the server and says, hey server, I would like to talk WebSockets with you. And when the server is okay with that, the server responds with a 101 response. Okay, that is an example for a 1 response. Now the 2 responses are very important. Everybody knows the 200 because that is a very good response. It just says, okay, everything is fine. But there are more HTTP responses which are relevant for our APIs. The first one that I would like to point out is the 201 created. 201 created means, okay client, you asked me to create a new resource and I created it. So when the client sends an HTTP post to the server typically responds with created, not with OK. Up until now, in the last exam and so on, when you created something, create a customer, for instance, in a database, you always return just 200. And from now on, we know that that's not a good idea. So this is especially important for the post requests, created post. The next one, the 202 accepted, is used if you do asynchronous processing. Think of the following. Maybe you have a business application and a client, a customer, would like to have a report generated. Unfortunately, generating this report might take a while. Maybe you have to create a 1,000-page long PDF file for this report. Such long-running operations are typically not immediately done by the server, but they are just scheduled, and when the server has time, it will work on such heavyweight processing. Asynchronous processing is the correct term here. And when you have a web API with which you can start a long-running process, then you will return accepted and not created or okay, because with accepted, you say, okay, I understand, I should do some asynchronous processing. I started it, or I accepted this request for long-running processing. Dear client, I'm not done, but I will start whenever I have time for that. Okay, good. 203, we will not talk about that in the moment. 204 is the next one. 204, you return that when the resource exists, but there is no content available. You know, this one is important for APIs. You should use it whenever you received a delete HTTP method. So if the user says delete customer 4711, then you do not respond with OK. You do not respond with created. It doesn't make sense. But you respond with no content. And with that you say, yes, this customer existed, but I deleted it, and therefore there is no longer content for this customer. Okay? So these are the most important four, let's do that one. These are the most important 4 HTTP status codes that you should remember in the 2 category. Okay? 2 means success. There are many other status codes which are useful and which are really served in practice. they are used in practice, but we will not talk about them. Maybe next year, or maybe you will use it in your internships when you build more advanced APIs, but currently these four, 200, 201, 202, and 204 are the ones that you have to remember, because from now on we are going to use them. Good. Whenever you have questions, please interrupt me, okay? Now, the three methods redirect. There are two important ones that you should remember. 301 moved permanently and 307 temporary redirect. Okay? 301 is important if you build an API and over time you decided to change the API URL structure. Okay, previously it was available at api.myserver.com/cust for customer, and now you change the name and you say it's now available at api.myserver.com/customer. Then you can, in the original API, return a 301 moved permanently, and then the caller gets an idea and says, I understand, this is no longer present here. So next time, the caller can remember that and directly call the new URL. To be honest, it's not that important. In many cases, you shouldn't break the naming at all. And if you break it, well, you break it. You can also document it. But if you want to build a really nice API, you should definitely leave behind a move permanently response. It is more important, to be honest, when you build interactive websites. Websites, for instance, which are crawled by search engines like Google. And then you should definitely add a 301 moved permanently if you restructure your page, because otherwise you lose all that valuable search results on Google, and you have to wait for days or weeks or months until customers can find your pages on Google again. Temporary redirect is essentially the same as move permanently, but only temporary. The name says it all, I think. It's not that important, and for APIs, we will probably in this course not use them at all. Now the 400 ones are way more important. They are as important as the 200 ones. The first one is very famous. It says 400 bad request. You should return a bad request whenever the client sends you an API request, which doesn't make sense. For instance, you have a web API for which you need, I don't know, a customer ID, and this customer ID must only consist of digits, 0 to 9 for instance, but the caller sent you a letter instead of digits. Then you have to respond with a 400 bad request. That means, hey caller, you did something wrong, I don't know what you mean. So 400 is something that you very frequently return from REST APIs, from web APIs. The next one is 401 unauthorized, and it is very closely related to 403, forbidden. Now, when do you use forbidden and when do you use unauthorized? Forbidden is used if the server is generally refusing to do what you ask the server to. For instance, you might have an API which allows you to get some data. For instance, you have a temperature sensor connected to a computer, and you send it certain data, and you can get this data from there. And if you try to delete this sensor, it doesn't make sense. You can say 403, forbidden. That is one option. But there is also, for this specific case, another option which you could use is 405, method not allowed. It doesn't make sense to send a delete method to this API. So 403 says, okay, you sent me something, I know what you want, but generally, no, this is not allowed. You cannot do that. I don't allow that. I forbid that. Use either 403 or in some cases 405. 401 is a little bit different. 401 means, okay, generally, What you want, dear client, is okay, but you specifically, you as the user or as the IP address, for instance, you are not allowed to do that. You don't have the necessary privileges. You need to either log in, sign in, or get different credentials, ask an administrator, unauthorized means. It is okay what you ask me to do, but I will not do it because you don't have the necessary credentials to do that. This is when you return a 401. Okay? Good. The most frequent one and most important one for this course is 400 bad request. The other things are very interesting. You can take a look at them. We will probably not use them in this course. In professional web APIs, it's very likely that you use at least some of them. And then we have the 500s. The 500s, the most important one is that one. For 500 means internal server error. Something bad happened on the server side. The database is not available, whatever. 500 means client, I can't respond to your request because I broke. So 500 is very common, and you will, if you want or not, return 500 every now and then. Whenever you make a mistake, it's very likely that you get a 500 or that you generate a 500. Okay? There is also a 501 that is sometimes returned if you already started with the implementation of an API, but you have not finished the implementation of the API. You might consider returning and not implemented. That means, client, I know what you mean, but this is not available yet. It will come later. To be honest, it's not that common. This is the one that you have to remember. Okay? Good. So what is the reason? Why did the world invent standardized response codes to HTTP requests? Why is that important? Why shouldn't everybody just come up with her own response codes? Everybody invents her own response code, and that's fine, isn't it? No, it is not. It is very important that you, if you build APIs, that you stick to these response codes. Because sometimes you have some network devices sitting in the middle, and these network devices could, for instance, do some logging. And they will take a look into your HTTP requests. And when they, for instance, see an HTTP request which with the status code starting with a 5, they can do some specific logging. They can send an email to an administrator. Something went wrong, but then it is important that everybody in this world returns server error with a status code starting with a 5. If on one server the status code would be 101 for an error, and on the next server the status code would be 301 for an error, nobody could implement, for instance, central logging, standardized logging tools, alerting tools, and things like that. So it is really important, and I will insist on that when you build professional web APIs, that you return the proper status codes. And in the next exams, either written exams or oral exams, it's very likely that I will demand that you respond with the proper error codes. And it might happen that I ask you a 400 a status code starting with a 4, what does that mean? And the correct answer would be, here you see it, it is a client error. Okay? So that is important. Just remember HTTP status codes. I don't know if I ever have mentioned that. There is also a very nice website which is called HTTP status cats instead of codes. And here you can see nice pictures for every different HTTP status codes. And of course, if you don't like cats, there are also HTTP status dogs and many other things. So if you go to HTTP status talks, you see funny pictures of dogs. Okay. Maybe it's easier to remember them if you take a look at the pictures of funny cats or funny dogs. So this was the status code. So let's recap. I repeat myself consciously. Which methods do we have? Get, delete, put patch. Which status codes do we have? 2, everything is okay. 4, client error. 5, server error. 3 were the redirects, and 1 were the protocol change, but they are not that important. 2, everything is okay. 4, client error. 5, server error. That is what you have to remember. Are there any questions yet? I am pretty sure that you have heard lots of the things that I told you now in other courses, but we will need this information available in your mind now, because now later on we will design APIs and we will use these things. This is why we are repeating that. Good. What else do we have? We have so-called headers. There are response headers and request headers. Headers are just key value pairs where the browser sends those request headers to the server, and the server responds with some response headers. What are some important request headers? Let's start with the request headers that typically are sent to the server. The first one is accept. Accept means that the client can send to the server which kind of data format he will accept. For instance, the client could say, hey server, I expect you to send JSON. Then the accept header would be application/JSON. Maybe the client says to the server, I only expect XML. Then it can specify that the server has to generate XML in the accept header. Currently, this browser here sends accept */*. That means essentially Google Chrome telling the server, I accept everything. Okay? The other ones are not that important because they are not that frequently used when building APIs. Some of them are pretty interesting and we could spend a lot of time talking about them, but I don't want to go into very much details. There are other request headers which I don't currently see here, but which are super important. And one of them is called authorization. They are for sending identity information to the server, okay? Let me quickly see if I can come up with an example. No, I will show it here on demo.hdp. How does that look like? For instance, if I send HTTP get HTTP api.myserver.com/api/something, and if I say authorization, this is the authorization header, and typically I could, for instance, say basic authentication, user : password, and then I will take this user and password and base64 encode it. That would be a typical authorization header. Sorry, I can't find now an example live, but this is how this would look like. This is the request header, authorization, and then here you have the kind of authorization. The most important ones that you typically see in the wild are basic. That means I specify username and password. And the second one that you frequently see is bearer. Bearer is for the modern authorization systems, like for instance Office 365 or Google Auth or Facebook Auth or Twitter. After the bearer word, you have a token. We will not talk about tokens in this course in very much details because we don't have the time and it's a pretty advanced stuff. But this, as I told you now, if you ever see this bearer stuff, then you can remember, this is authorization based on the OAuth 2 standard, and this is the de facto standard for all platforms out there which are modern and new, like I told you, Google and Microsoft login and Facebook login and Twitter login and all these things, they are using Bearer auth. But if you build a simple API, sometimes it's pretty okay to use basic and then specify username and password. But username and password are always base64 encoded. This is not encryption. This is just encoding, okay? You can, without any password, decode it and see username and password again. So this is a typical example of an authorization header, okay? Good. Let's go back to this example. I hope this is okay and you understood what I meant with that. Now, with response headers, this one, the server can send some additional information back to the client. And one of the most important one, we saw that before on the other website, is cookies. The server can send cookies to the client, and of course the client will then send these cookies back to the servers. What are cookies? Cookies are called cookies because of Red Riding Hood. Because of Rotkäppchen. Can you remember how Rotkäppchen found her way out of the wood again? I think they took bread or cookies and they just put crumbles on the floor, and then they followed these crumbles back, and with that they found their way home. I think it was Red Riding Hood, wasn't it? I think it was that. Was it Hansel and Gretel? Oh, I'm very sorry. It was, yeah, I'm sorry. Yeah, it was Hansel and Gretel. I don't know the English name for that. I'm sorry, I'm not an expert in tales, okay? I'm sorry. You are absolutely right. And this is what cookies are all about. So the client receives some cookies from the server, and later on, when the client visits the same server again, the client will send the cookies that it originally has received from the server again back to the server. And with that, the server can relate different requests to the same origin, or it can round trip some data. It can send some status information to the client. The client will store it and resend the status information with every subsequent request. For instance, identity information. Who is the user who is currently signed in could be stored within a cookie. Okay, cookies are important and cookies aren't bad. Many people think that cookies in general are bad. They are not, because cookies are typically local for a single web application. What is a little bit bad is cookies which are global. So you can set global cookies that the client will send to every website that the client visits. Nobody uses global cookies anymore. There are also third-party cookies, so cookies which are sent by or which are set by some embedded whatever stuff, for instance, some Facebook icons on the page, and these third-party cookies can be tracked by companies like Facebook to find out which websites you as a user visit, so they can understand where you are spending your time on the internet, and therefore they can send you tailored marketing. So therefore, third-party cookies are something which are not very good, which is not very good and typically not appreciated by end users. But local cookies, if you work with, I don't know, myserver.com, and myserver.com sets a cookie which is only accessible for myserver.com and which is just used by myserver.com to store some status information about the connection of the user, they are fine. Because you are working with this server, you want to work with this server, and only this server can read those cookies. So these kind of cookies are perfectly okay. When you build web APIs, cookies are often used for authentication. So you are sending, for instance, your username and password only once, then the server sets an encrypted cookie for the response in the response header. And when the user calls the next API, the browser will resend the cookies with the identity information to the server again. And with that, the server knows who the user is. And because the cookie is digitally signed and or encrypted, the server can make sure that those cookies are have not been tampered with. Nobody has did some strange things with it to take the identity of a different user, because then the cookie would not be digitally signed anymore, and therefore the user can understand that something went wrong. So cookies are relevant for APIs. Probably in this course, I will not show you how to use cookies, how to send them, and how to use cookies for identity, because that is pretty complex stuff. It's powerful stuff, but it's complex stuff. And therefore, I just wanted to tell you for what cookies are used for what, and now you know it, and you know cookies, APIs, identity, very often used for identity. These are the response headers, setting cookies for instance, and the request headers, sending cookies. The last thing that I would like to show you is the query path. Of course, we can send some information to this URL by appending some parameters like this. These things are called query string parameters. Okay? And if I run this, of course, it doesn't make sense. We have it anywhere. Here you have query parameters. They are called query parameters. Query parameters, just to refresh your mind, I'm pretty sure you know that. The first one after the URL is a question mark, and then you combine them with an ampersand, okay? If you go down in Google Chrome is parsing these query string parameters and show you the query string parameters down there, so you see it pretty easy, and it's easy to understand. If you go to view source, you will see this long string, and if you click on view parsed, you will see all these nice things. And if you click on view decoded, then you will see that these encoded special characters are really nothing else than blanks, for instance. A %20 is just a blank. And if you don't know what this %26 is, just click on view decoded and you will find out that this, that this is the ampersand character. So this is pretty useful stuff here in Chrome. Okay? Of course, obviously, query string parameters are heavily used in API design. Good. So let's recap. Server name, request method, status code, request headers, response headers, query string parameters. Yeah, and the path, of course. I didn't mention that, but I think, of course, everybody knows what the path is. This is the path. Yeah, I didn't mention that explicitly, but I think you know. Okay? And all these things are used when modeling APIs. When we build APIs, we are using all these things to specify operations, to pass parameters, to work with authentication and things like that. Good. This was the first hour, and we were just recapping things that you probably have heard already in previous courses, but they are important. And I repeated them because now, in the next hour, we are going to use all of them when designing an API. Okay, so I hope you were not bored. If you were bored, that's fine, because then you know, okay, I know all the things that I need to know. In the next hour, you will be very well equipped. And if you like this quick refresh, I'm happy, because now we have it fresh in our mind and we can use it to design APIs. Do you currently already have questions regarding the HTTP protocol and the components of the HTTP protocol, which we are going to use for APIs? Yes, very good question. What is the difference between put and patch? Put is for updating an entire record. Imagine that you are building an API with which I can manipulate customers. Then you can create an endpoint with which I can update a customer record. That would be a put request. With a put request, I have to send the entire customer record to update the fields. So I send the customer's first name and last name and address and town and country and whatever a customer is made of. So for put requests, you have to send all the data to the server. But that is somewhat inconvenient if you just want to update a single field. For instance, if only the telephone number of the customer has changed, why should you send the entire customer record to the API? First name hasn't changed, last name hasn't changed, only the telephone number has changed. So for those cases, the put request is a little bit inconvenient. So therefore, the patch request has been invented or is used. The patch request patches only certain fields of your state. So you can send a patch request with just the changed telephone number of the customer. And you expect the API to leave everything as it is and just update the telephone number. Do you understand the difference? Put, send everything. Patch, only send the changed data items. Understand what I mean? Okay, for simple APIs, you typically do not implement the patch request. Patch is a little bit more advanced. It takes more programming also in C#. So for our exams and for our homeworks and so on, you can expect that I only ask you to implement put requests in this course. I will probably not ask you to implement a patch request because that's somewhat more complicated. But if you want to see how it works, just Google it. Google ASP.NET Core patch requests and you will probably find some YouTube videos or documentation pages or blog posts where people show you how to build a proper patch request in ASP.NET Core. Further questions? So we are perfectly in time. It's 9 o'clock. We now worked for 1 hour. We will now have a short break, okay? We will meet again at 9:15, so you have a little bit more than 10 minutes to maybe grab a coffee, something to drink, a snack, whatever. At 9:15, we will meet again, and then we are going to take a look at Swagger. The Swagger protocol, the Open API specification is the more senior way of putting it. And then we are going to design an API, not implementing yet, but we are going to design an API with Open API specification. And in the third hour, we will then implement this API based on our design written in Open API specification. This is what we are going to do today in the upcoming hours. So for now, enjoy the break and be right back at 9:15. See you in approximately 10 minutes.